All right, so we're in part 5 of section 9.4, and before we go on, we have to remember something because it might be a while since you've done any factoring the sum of cubes or the difference of cubes. Now, if we have the sum of cubes, that factors into or x plus a times x squared minus ax plus a squared, okay? And so maybe what you had was x cubed plus 8. Well, remember 8 is 2 times 2 times 2, so that's 2 cubed. And so this is going to be x plus 2, x squared, and then minus 2x plus 2 times 2 is 4. And so that's kind of what that would look like. All right. Now here, maybe you had x cubed minus 27, and if you have 3 cubed, 3 times 3 is 9, times 3 is 27, then you use the x minus a times the x squared plus ax plus a squared. And if you notice, we have a plus here, we have a minus here, we have a minus here, we have a plus here. Otherwise, everything else looks the same, and we just keep the same sign for that first term, and we just change it for the second one, okay? So in this case, we would have x minus 3 and x squared plus 3x plus 9, okay? And if you notice, that's irreducible because that's part of how we factor this, and we can't factor it anymore. And so that's most likely how the rest of these are going to be, as far as if they don't give you the factorization where a quadratic is not reducible, then you're going to get something like this where you have to factor a sum or difference of cubes. All right, so let's try one, and this is the one we're going to look at. And guess what? Oh wow, I chose the same one. Didn't even know that. All right, anyway, well, x plus 2 cubed is what this is. And so really we have a minus 5x squared plus 18x minus 4 all over. Now remember, the first one's the same, and so it's going to be x plus 2. And then we have an x squared. Now we have to change the sign, minus 2 times x plus the x squared, which would be 4. Okay, and so that then is going to be our factored denominator. And so let's go ahead and just put an arrow here, so then we can say, well, that's equal to, well, our first term, a, just has x plus 2, so we don't have to have any extra stuff here. But that second term is an unreducible quadratic, and so we're going to have bx plus c over x squared minus 2x plus 4. Okay, so what are we going to do? Well, we're going to multiply this whole thing times x plus 2 times x squared minus 2x plus 4. Okay, so when we do the first term, guess what? The first term, we just get minus 5x squared plus 18x. And then I'm going to put a plus there again, but it's a minus 4. All right, and we get here. Well, the x plus 2's cancel, and so we get a times x squared minus 2x plus 4. And then we have plus, now we have bx plus c times what? Well, the x trinomial basically cancels, and we just have x plus 2 we have to multiply. All right, so going on down, minus 5x squared plus 18x minus 4 equals, now that's ax squared minus 2ax plus 4a plus, now we have bx times x, so that's bx squared, bx times 2, so that's plus 2bx, c times x is cx, c times 2 is 2c. So now we're at the point where we start underlining in different colors. So let's keep this one the same, I guess. So we have x squared, x squared, x squared. Now let's go maybe red. So we have x, 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 x. And then maybe we have our number, and our number. Okay. So now let's write those equations. So we have a minus 5 equals a plus b. Okay, we just have a and b. Then we have 18 equals, then we have a minus 2a, and then plus 2b plus c. Okay, and then our last one, we have a negative 4 equals 4a, and then we have plus 2c. All right. So that's not too bad. So what do we want to do here? Well, if we combine these, what we could do is we could eliminate maybe the b, and then we have an equation with a and c, and this equation has a and c. I think that's probably what I'm going to try to do here. So just kind of glancing at it, that looks the most. So I'd have to multiply that first equation by a -2. So -2 times -5 is going to give me a 10 equals minus 2a minus 2b. Okay. And so now I'm going to take those two equations and I'm going to add. And so this is going to be first, and then this is going to be add, and that's going to be second. And so 10 plus 18, that's going to be 28. Minus 2 is minus 4a. And then b's cancel, and then I have plus c. And now I have, okay, well, here, I can just add those because guess what? The a's are opposite signs, so now I'm going to add those third. And so 28 minus 4 is 24 equals, a's cancel, and I have 2 plus 1, so that's a 3c. So here, if I divide by 3, c is equal to 8. Okay. And now I can just work my way back up and solve for the rest of them. So if I plug it, c is 8 in here, then I have a minus 4 equals 4a plus 2 times 8. So I'm going to subtract 16. And so it's minus 20 equals a 4a. So a equals a minus 5. Okay, so that looks good. Now what do we need? We need b. So if we do that, minus 5 equals a, which is a minus 5, plus b. Well, if I add 5 to both sides, b equals 0. Okay, so with b equals 0, this piece of the term falls out. And so really all I have is a, which I said was negative 5, over x plus 2, plus b is 0. So then I just have to plug c in, which is 8, over x squared minus 2x plus 4. And so then that is my partial fraction decomposition of this original fraction here. Okay. And again, this time our x term fell out. We just have the minus 5 and the 8, and that's all we have. All right, so what about this one? Well, this one we have a difference of squares. So with the difference of cubes, what we have is this is 5 cubed. So what we're going to get is x squared plus 2x plus 40 over, and then we'll have x minus 5 times x squared plus 5x plus 25. And that's going to be how we factor that one. And so we're going to get out of that a over x minus 5, and then bx plus c, because remember, when you have a quadratic that's irreducible, you're going to do this bx plus c, and that's the x squared plus 5x plus 25. Okay. Now we multiply by that common denominator, and we get x, oops, I don't know why I like to put plus. I guess I like to be positive. X minus 5 times x squared plus 5x plus 25. And so from there, when I multiply that first one, I just get the x squared plus 2x plus 40. Now when I multiply the next piece, the x minus 5 cancels, and I'll have a times x squared plus 5x plus 25. And then the next time I'll have plus bx plus c times, and those cancel, so I have just the x minus 5. Okay, now I distribute here and FOIL here. So that's going to give me ax squared plus 5ax plus 25a plus, now bx times x is going to be bx squared. Bx times a minus 5 is a minus 5bx. C times x is cx, and then I have a minus 5c. All right, so x squared, x squared, x squared. Then I have x, 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 x. And then we have a number, and a number. And so this one's probably going to go about solving kind of like the way the last one did. And that being that we're going to have, terms where we just kind of have to add two equations together, then add another two equations together to eliminate things. And so we have 1 is equal to a plus b, and then the next one says 2 equals 5a, then minus 5b, and then plus c, and then the next one says we have 40 equals, and we have 25a minus 5c. Okay. And if we remember last time, what we did is we added the first two equations together, got rid of the b, and then we had an a and a c together, which then we could add to the last one, and that looks like this is going to be the same thing we do here. I'm going to multiply this equation times 5, and that's going to be first. And so then I get a 5 equals 5a plus 5b, and then I'm going to add those two together second. And so 5 plus 2 is 7 equals 5, and 5 is going to be 10a, and then those cancel. Okay. And, and oh, then I have also the c. I forgot the plus c. 10a, and then plus c. It's like, that's kind of weird because I get it to stop already. All right, so 10a plus c. And now I've got this equation and this equation I can work with. But it looks like I'm going to have to multiply this one times 5 first. So maybe I should get rid of saying I'm going to work with those two equations until I get the one I need. And so that'll give me 35 equals 50a plus 5c. And now I have these two which I can work with. So 40 plus that's going to give me what, 75 equals. Here I have 25 plus 50, so that's a 75a. My c's cancel, so I guess I get a equals 1, so that was nice. Now I can plug that back into the first equation. 1 equals 1 plus b minus 1 minus 1. Guess what? B equals 0 again. And so because of that, I can solve this equation or this one. It really doesn't matter. And so if I do maybe the second one this time just to be different, I'll have 2 equals 5 times 1 minus 5 times 0 plus c. Well, that's 0. 5 times 1 is 5. So if I subtract 5, I get c equals a negative 3. So now I can plug all that back into this, and I get a, which we said was 1 over x minus 5, plus b, which said was 0, so no x, and then c is a minus 3 over x squared plus 5x plus 25. And then that is my partial fraction decomposition of my original fraction that they gave me. All right. So that's into part 5, and what we'll do is we'll come back with part 6, which is another way to do partial fraction decomposition.